Um, Hello everyone. So in this video, we will talk about the p-value in hypothesis testing. So what we did so far is we just, for a given any typical alpha value like 0.01, 0.005 or 0.10, we just conduct our hypothesis test. How? Well, so scientists don't have computers, so what they do is they just looked at the critical values from the tables. So tables are pre-defined or pre-calculated. Then they just calculate their observed Z or observed T or observed whatever they have, okay? And then compare it with the values from the table and give their decisions, okay? Whether so um, whether the observed value is in the critical region or not, they just give their decision. Well, this is easy, but it's a type of yes or no. So it's a yes or no type of decision, okay? You either say yes or say no. So well, even in modern approach, what we do is we prefer not to fix the alpha value, okay, that the level of significance in advance, but we just use the p-value. So what does it mean, and what does it mean in general, being a yes or no type of question? So let's test um, the hypothesis where the height of the students in the university is 170 versus it is greater than 170, okay? And sigma is equal to 10 with, I just take 25 many students, and let's say alpha is equal to 0.05. Now, the critical value is z sub 0.005. Since this is a greater type of question, so the critical value is at the right-hand side. So I have this. This is my normal distribution, okay? This is z sub 0.005, which is equal to 1.645. And this is what? This is your alpha, which is equal to 0.05. Great. Now, assume that I just pick a class and its average is 173.25. Okay. So let's calculate the z observed here. Z observed here is equal to 173.25 minus 170 divided by sigma divided by root n, which is 5. Okay. So this is equal to 3.25 divided by 2, which is equal to 1.6, right? 625, right? So do we reject the hypothesis? Well, no, right? Because it's not greater than the critical value, z sub 0.005, so we don't reject the hypothesis. So let's look at the average. Assume that the average of 25 many students is 173.5. So there is a very little difference here, okay? So the z observed is equal to now 173.50 minus 170 divided by 10 divided by 5. That's equal to 3.5 divided by 2, which is equal to 1.75, right? Well, do we reject the hypothesis? Yes, okay, we reject the hypothesis. So there is a very little difference, and by just looking at this difference, in one case we just reject the hypothesis, we don't reject the sorry. In the second case, we reject the hypothesis. Okay, so as I said, this is a yes or no type question, yes or no type of question. So what is the definition of a p-value? P-value is the lowest level of significance at which the observed value of the test statistic is significant. Okay, so it's the lowest level of significance, right? At which the observed value of the test statistic is significant. So a small p-value provides evidence against H0. Okay, so if you have a small p-value, it means that, well, your null hypothesis um, is not very strong. It's not credible, right? So we reject H0 whenever p-value is too small. So p-value, as I said, is the measure of credibility or plausibility or acceptability for H0. So if you have a small p-value, it discredits H0 and encourages us to reject the null hypothesis. Okay. So the definition of p-value it was Well, the lowest level of significance at which the observed test statistic is significant. How do we calculate it? So it's the probability that the observed value of the test statistic can be as extreme as or more extreme than the value of the obtained from the sample, assuming that the null hypothesis H0 is true. Okay. So the p-value gives the decision maker the chance to make a personal judgment about the following. Well, is this value of the test statistic reasonable and can be assumed to be supporting the null hypothesis, or is it too extreme to be considered acceptable and thus constitutes strong evidence against H0? Right? So it's not something very new. We will have an example and you will understand what I mean. So just consider the same example that we did so far. A random sample of 100 recorded deaths in Turkey. Well, the average lifetime is 71.8 years. Okay, so X bar is 70.1. Well, I want to test the following hypothesis. Mu is smaller than or equal to 70. Recall, this is same as testing mu is equal to 70 versus mu is greater than 70. And sigma is equal to 9. Okay? Well, just make this hypothesis testing using 0.0 level of significance and use p-value approach. Okay? So before getting there, so what we will do is now remember the p-value. P-value is the probability, okay, is the probability of getting extreme or more extreme than the observed test statistic, okay? So it was the definition. So what is my observed test statistic? Is the observed. The observed is equal to 71.8, right? Minus 70, which comes from the null hypothesis, divided by sigma, divided by root 10, which is 10. So this is equal to 1.8 divided by 0.9. That's equal to 2. So this is my test statistic, okay? The observed test statistic value. So let me just plot the distribution of the null hypothesis, distribution of the standard norm random variable. This is 2, okay? This is 2. Now, what is the definition of the p-value? P-value is the area to the right of this number, okay, to the right of t. So what is this? What is this? This is the probability of getting extreme as or more extreme than your observed z, observed test statistic value, okay? So these are the extreme values. So the probability of getting more extreme than 2 just gives you the p-value, okay? So the p-value here is the probability that z greater than 2. Okay, this gives you the p-value, right? So what is the value of that? Just look at here. The probability that z is greater than z observed, z is greater than 2, that's equal to 0.023. Okay, so this is your p-value. By the way, you can also calculate it as just like this. So if you just take your test statistic as your x bar, so what is the probability that x bar is greater than 71.8? Just make your conversion, x bar minus mu, remember your conversion, x bar minus mu divided by sigma divided by root 10, and make the same conversion here, 71.8 and 70 divided by sigma divided by root 10, okay? So it's here. So this is z greater than this, which is z greater than 2. It's the same thing here, right? It's the same thing here. That's equal to 0.023. So this is my p-value, okay? This is my p-value. So let me just again plot it. So this is my p-value. So this is 2, right? This is 2. And the area to the right of 2 is equal to 0.023, right? So when you're solving a question with p-value, there are two options. One option is in the question, you might be given an alpha value. Okay, so in this question, what was the alpha value? In this question, the alpha value is 0.05. Okay, the question says that just answer the question, answer the results, give the result of the hypothesis test using significance level of alpha, which is 0.05. So alpha 0.05 means that, well, just take your critical region so that to the right of this critical region, there should be an area of 0.05, okay? Since this p-value is 0.023, which is smaller than 0.05, it means that, well, the critical region is just here, okay? It's here, right? So this is my critical region. So this is 0.05. So since, now I can just write here, since 0.023 is smaller than the given alpha value, okay, so which is, since p-value is smaller than the alpha value, okay, then we can say that we reject H0, okay, at this alpha value, at alpha equal to 0.05 value, right? So if your calculated p-value is smaller than alpha, what does it mean? It means that, well, so p-value is associated with the observed, okay, and alpha is associated with the critical, let's say. So if p-value is smaller than alpha, well, so this is associated, right? Associated with, right? So if p-value is smaller than alpha, if p-value is smaller than alpha, it means that you will reject the hypothesis at this alpha level. Okay, so this is option one. What is the second option? In the second option, they don't give, so this is your first option, okay? So let's say option one, okay? And the second option, let me just write it here, option two, in option two, nobody gives you any alpha value, okay? There is no alpha value, no alpha value. Then, if there is no alpha value, the rule of thumb is, if p-value is smaller than 0.10, then you can reject the hypothesis, okay? Reject HCU, right? So in general, we generally assume that 0.10, okay, 0.10 can be used as a threshold for p-value to just reject the null hypothesis, okay? So consider the next example that we did for the manufacturer. Remember, there was a new synthetic fishing line, okay? So I just want to test whether mu is greater than 8. Recall this as mu is equal to 8 versus mu is smaller than 8. Well, what is the p-value associated with this? So remember, here we just make the test using alpha equal to 0.01, and hence so remember, we just use alpha equal to 0.1, and we say that, well, don't reject the hypothesis, don't reject the H0, okay? So, well, let's try to see what is the p-value. So x bar is equal to 7.85 kilograms. And now what is the p-value? So the p-value will be, okay, let me see whether we have it or not. So p-value, the probability test testing is more extreme than observed value. So this is your observed value that's calculated, x bar 7.85 minus mu 0.8 divided by sigma divided by root n, which is equal to minus 2.12. Okay, so here let's plot this. So here this is the standard normal, but this time it's not here. Okay, it's not here, right? It's not here. So it's, let me just erase that thing. Okay, so okay. Now what I have is, I have, it's on the left hand side, right? Because this is mu is smaller than type of hypothesis testing. So your observed value is here, minus 2.12. Okay. Then being extreme or more extreme than the observed value means that being smaller than your observed value, okay? Since this is the smaller than type of alternative hypothesis, then being extreme means that the value, the probability to the left of minus 2.12. Remember, in the previous question, it was there, okay? Um, in the previous question, it was here because it was a greater than type of question, mu is greater than 70, Okay, so this is greater than, but here this is smaller than. Hence, we just look at the to the left of the observed value. So the probability that z is smaller than minus 2.12 is 0.017. So you see, at alpha equal to 0.01 level, we don't reject it, okay? We don't reject the hypothesis, but p-value is too small, okay? So it turns out that, well, the Sankt has at least 8 kilogram does not have much credibility. Hence, the wholesale store, which was Decathlon in our example, well, they must think twice before they purchase the large quantities because as we say, well, this hypothesis can be rejected only at alpha is equal to 0.01 level. So if you are not given alpha level, you may say that, well, I just reject the hypothesis and say that, well, mu is smaller than 8. Right? Well, this was the case when we just used the p-value in single-sided hypothesis test, right? So we just used the p-values in single-sided hypothesis test. How about two-sided hypothesis test? Well, the only difference is that we just multiply the probability by 2, okay? So the only thing that you should be careful about is, well, whether the alternative hypothesis is greater side or the lower side, okay? Just calculate the probability accordingly, then just multiply it by 2. So let's reconsider the previous example for the synthetic fishing line. Just like mu is equal to 8 versus mu is not equal to 8. Okay? So now the p-value will be just 2 times probability z is smaller than minus 2.12, which is equal to 0.034. And similarly, the lifetime of people in Turkey, well, the p-value will be, so, okay, I forgot to write the 80. I just added, well, for lifetime of people in Turkey, let's take this, let's test the hypothesis mu is equal to 70 versus mu is not equal to 70. Then the p-value is just 2 times probability that z is greater than equal to 0 observed, which is 2 times probability z is greater than 2, which is equal to 0.046. Okay? Well, let's find the p-value for example, in hypothesis testing for the variance. Okay, so a manufacturer of car batteries claims that the life of the company's batteries is approximately normally distributed with a standard deviation of at most 0.9 years. Well, to test if the standard deviation can actually be larger, okay, so I just want to test whether it is larger, okay? So I just take 10 of these batteries and just test them. And it turns out that the standard deviation is 1.2 years. So S is equal to 1.2. Remember, what was the claim? The claim was sigma is equal to 0.9, right? So, well, do the data support the manufacturer's claim? Just use a 0.05 level of significance. So first, in order to find the p-value, I just calculate the chi-square observed. Okay, chi-square observed is n minus 1, remember, times s squared divided by sigma square. So this is equal to 9 times 1.44 divided by 0.81, which is equal to 60, right? So this is a chi-square, what? This is a chi-square random variables plot. Um, so it's somewhere here, right? 16. So what is the p-value? The p-value is the area to the right of this, okay? So the p-value is the probability that a chi-square random variable with 9 degrees of freedom is greater than 16, okay? So this area. It turns out that the area is 0.067. So how can you calculate this? Well, you cannot find this from your tables because since chi-square and t and f has degrees of freedom, you cannot calculate the p-values directly from the tables. So what you can do is you can just use Excel. So in Excel, what you can do is just find the chi-square distribution. So this is f of chi-square, capital F, the cumulative distribution. You just write capital F, okay, 16. So this is 16 there, okay. And this is what? This is the degrees of freedom, okay, degrees of freedom. And this one says that, well, just this is F, okay. So if this is 0, if this is 0, then you have the small f, okay? The probability density function. If it is 1, that's the cumulative function. This is f, right? So if you just subtract it from 1, so this is capital F. The capital F just gives you the area to the left of the scalar, okay? So to the left of 16. So 1 minus capital F just gives you this side.